Today starts Chapter 21, Hydrocarbons. Remember, you have a quiz on Friday on this. So less than 200 years ago, organic compounds found in nature had to be produced by living organisms. Organic means from an organism. So plants, skin, oil, coal, anything like that was produced by living things. Today, organic chemistry includes essentially every carbon compound out there, regardless of how it was formed, except for CO2, carbon dioxide, and the carbonate ion. So that would be a good quiz question. What is not considered to be organic, but it has carbon? There are more than 1 million carbon compounds, and it's because of the way carbon can bond. Since carbon is found in group 14, it has 4 valence electrons, and it needs 4 more to form a stable octet. So carbon is going to find a way to form 4 bonds. It can do this with a single bond, a double bond, or triple bonds, but some combination so that it reaches 4 bonds, or a total of 8 electrons. So here we see group 14, and carbon belongs to the group. So it has 4 valence electrons. A hydrocarbon is an organic carbon that contains only carbon and hydrogen. A hydrocarbon, hydrogen and carbon. The simplest hydrocarbon is methane. We have to know molecular formulas versus a structural formula. Although a ball and stick model helps visualize it better, we're really only going to concentrate on the first two, molecular and structural. Carbon atoms bond to other atoms. Again, it can form a single bond, but somehow it needs to have 8. It can form a double bond. And notice how we represent a double bond, which means 4 electrons or 2 electron pairs. But still, it has around, the carbon has around it 4 dashes, which represents 8 electrons. Carbon can also form triple bonds, where 3 pairs of electrons are shared. But still, overall, each carbon has to have 4 bonds. A straight definition is what we mean by a saturated hydrocarbon. A saturated hydrocarbon contains only single bonds. S for saturated, S for single. If a compound with carbon has only single bonds, it's considered to be saturated. That would be a good quiz question too. Unsaturated hydrocarbons contain at least one double or triple bond. Hydrocarbons are refined, and by hydrocarbons we really mean petroleum, in a process called fractional crystallization. But really it's just a way of separating out higher molar mass compounds from lower molar mass compounds. I'm not really going to get into asking you about refining hydrocarbons. A homologous series is a series of compounds that differ from one another by a repeating unit. For us, this repeating unit is going to be CH2. So CH2, the next compound would be C2H4. In other words, we're just increasing by a CH2. The next compound could be C3H6. 6. Actually, we have to strike this. The first compound is actually methane, which is CH4. Sorry about that. So now to the CH4, we keep adding CH2s. So the next member would be C2H6, and the next member would be C3H8. And then it can continue on and on. The first type of hydrocarbon we're going to look at is what we call a straight chain alkane. It's a straight chain hydrocarbon. They are considered to be saturated because they contain only single bonds. There's a formula for the alkanes, which you won't have to memorize because I'm going to show you where to find it in a few seconds. As the size of an alkane increases, as the molecule increases, the force of attraction gets greater or larger, and the molecules will change from gases to liquids, and eventually, when the force of attraction is great enough, to solids. Now, one of the fun parts of hydrocarbons is starting to name these different compounds. So we have a couple of reference tables that we're going to look at. So I'm going to bring up the reference table quick, and I'm going to scroll down until I find Table P. Table P is a prefix for the number of carbons found in the longest chain of the molecule. So you don't have to memorize these, but have your reference table out and open because we're going to do a few of these coming up. So if you have 3 carbons, the prefix is prop. If you have 8 carbons, the prefix is 8, or is oct. Now, in table Q, we have the name of the general form, the name of the series we're going to look at, and the general formula. So tomorrow, one of the questions I'm going to ask is what is the general formula for the alkanes? So what you really need to do is just know that you have to look at table Q. So you may be given a structural formula and ask to name it, or you may be given a name and ask to draw it. So either of these is legitimate for asking a question. So back to the notes, but keep open those tables. And here we see in the chart propane. Propane with the prefix prop means there's 3 carbons. Ane means it's an alkane. So the formula is CnH2n plus 2. So if you have 3 carbons, then 2 times 3 is 6 plus 2. You have 8 hydrogens. We draw a single branch chain of carbons and then just connect them with 4 dashes, which would be filled in with hydrogens. So let's say I ask you to draw pentane. What's the formula for pentane? Well, pent from table P means 5. Then the number of H's is double the number of carbons plus 2, so it's 12. We would then draw 5 carbons in a row with a dash between them for the pent, And then we can complete each structure so that each carbon has 4 bonds. And then we fill the bond sites in with hydrogens. And in the end, we have 5 carbons and 12 H's. So go ahead and draw octane. Step 1, what's the formula? So C oct is 8. Excuse me. Octane, anes, we double the number of carbons plus 2 to get the number of H's. 8 times 2 is 16, plus 2 is 18. We draw 8 carbons. Each carbon needs 4 bond sites. And we don't have to draw the H's in. The H's are understood. So it kind of saves us a little bit of time from taking the time to put the H's in. So now let's work backwards, or the other way. What if I gave you this, and I asked you what its name is? Since there's only 2 carbons, we can fill the H's in. So the formula is C2, H6. We know it's an alkane because we double the number of carbons plus 2 to get the number of H's, which is 6. And 2 carbons is called eth from table P. So this is ethane. So we'll practice it, but you need to be able to write the structural formula from the name or to write the name from the structural formula. So that's it. You have your quiz. It'll be 5 questions based on this lecture. So we'll see you on Friday. Bye.